Hi, this is Calandra. In this video, we will be covering combining like terms and the distributive property. Like terms are terms that have the same variables, including the same exponents. To add or subtract algebraic expressions, they must be like terms. So only like terms can be added and subtracted. And to combine them, you will just combine their coefficients. The exponents do not change when you're adding and subtracting like terms. So keeping that in mind, let's simplify the following expression. So first thing I want to do is to identify my like terms. So x cubed and 10x cubed are like terms, and 12x and x are like terms, and that looks like that's it. So to combine them, we just combine their coefficients. So the coefficient of x cubed, since there is not one written, is understood to be the number 1. So we'll have 1 minus 10, which is a negative 9, and the variable stays the same. Next, because it's a good form to write your variables in descending orders of power, you don't have to do that, but it just makes it easier to read. So since we've taken care of x cubed, I'm going to go with my x squareds next. There's only one x squared term, so I'm just going to bring that down and keep it as negative 5x squared. Now I need to combine my x terms. So I have a 12x plus a 1x, which will give me a positive 13x. And then I just have one number, or constant, and that's 12. So we don't have any like terms left, so this would be my simplified expression. Going on to part B. Here we have two like terms, xy and 3xy. Even though x squared y has the same letters, since we have an x squared, it is not a like term with the ones that I have underlined there. So to combine our like terms, we're going to add or subtract just the coefficients. The coefficient of xy is understood to be 1, so we'll have a 1 plus 3, which is 4. The variable stays the same when you're adding or subtracting, so 4xy. And then we still have minus 2x squared y minus 5. And there's nothing else we can do with that. To multiply algebraic expressions, we multiply the coefficients together and add the exponents of common variables. Okay, and we'll look at an example of this in just a moment. Also, when multiplying, we're often going to have to apply the distributive property. So if you have a quantity being multiplied by another quantity in parentheses that's being added or subtracted, you have to make sure to multiply the term on the outside by both things on the inside. In other words, you have to distribute. So A times a quantity B, and it doesn't matter if you have a plus or a minus, C is going to equal A times B, and then you preserve whatever sign you had, and then you also will have that number on the outside, A times C. Okay, distributive property is very important, so you want to keep this in mind. So for our first example, to simplify this expression, I see that I have something outside of my parentheses, so I will have to use the distributive property. So I'll be multiplying that 3x squared by 5x to the 4th, also by negative 2x cubed, and also by that x on the end. So 3 times 5 gives me 15. X squared times x to the 4th. To multiply those, you add your exponents together, and that gives us x to the 6th power. Next, I have 3 times negative 2, which gives me a negative 6. X squared times x cubed, we add the exponents together to get x to the 5th power. 3 times, since there's not a number written there, there's really a 1, So 3 times 1 is just 3. We still have our positive. X squared times x, remember x is the same as x to the first power. When you add those exponents together, that gives us x cubed. We don't have any like terms that we can combine, so this would be our simplified answer. Okay, moving on to example B. For this one, at first glance it may not look like something where you have to use the distributive property, but we actually do. We have a negative outside of our parentheses. So since there's no number written here, remember that there's an understood 1. So we're actually multiplying -1 by everything inside of our parentheses here. So we keep 7x squared plus 3. -1 times x squared just gives us a -1x squared, which we can just write as -x squared. -1 times -4 gives us a +4. So now we have some like terms, 7x squared and -x squared, and then also 3 and 4. Okay, so remember that there's really a 1 in front of that x squared. So 7x squared minus 1x squared will be 6, and the variable stays the same, x squared. 3 plus 4 is 7, and that would be our answer. Okay, for part C, we have two binomials being multiplied together. So we can use the distributive property, or, well, it is the distributive property, but a common way, that method that's taught to multiply two binomials that you may have heard of before is FOIL. I'll show how you can also multiply this out just directly by using the distributive property. But let's start off with FOIL, because I think a lot of students find this the easiest way to approach it. The FOIL means that you're going to start by multiplying the first terms together, then the outer terms, then the inner terms, and then the last terms, and they're all going to be added together. Okay, so our first terms would be the x and the x. Okay, so x times x gives me x squared. Then we do plus. Now we multiply the outer terms together. So x is on the outside, and this -5 is on the outside. So x times -5 is -5x. If you wanted to start by just making it subtracting 5x, that is fine. Okay, plus, now we need to deal with the inner terms. So 2 and x, notice how those are on the inside of our two sets of parentheses. So those are the inner terms. 2 times x is 2x. And then our last terms, 2 is the last one in our first set of parentheses, and 5 is the last one in our last set of parentheses, plus. So 2 times -5 is -10. So now we have a problem of just combining our like terms. So I have a -5x and a 2x. When you combine those coefficients, -5 plus 2 is -3. Variable stays the same. We do not want to write plus a negative, because plus a negative is the same thing as subtracting, so we should write that as a -10. And that's our answer. If you did not want to use the FOIL method and you would rather just apply the distributive property to it directly, this is how you could have solved that same problem. So we have x plus 2 times x minus 5. So you can think of the first set of parentheses as one quantity that you have to multiply by everything inside of your second set of parentheses. So I know I'm going to have my x plus 2 using the distributive property times that x. With distributive property we're always adding, and then I have to have that quantity again, x plus 2, times the other part of my parentheses, which is negative 5. Okay. So we can rewrite this if needed, but it doesn't matter where your term is written when you're multiplying by what's in parentheses. You're probably noticing you're going to have to use the distributive property. I'm just going to rewrite it this way for clarity. So we have x times the quantity, x plus 2. And then we can put this minus 5 in front. We can leave it as plus a negative 5 times x plus 2. So now when we distribute, we have to distribute the x, and then we need to distribute the negative 5. X times x is x squared. X times 2 is 2x. Negative 5 times x is negative 5x, so I'm just going to go ahead and write that instead of doing plus a minus. And then negative 5 times 2 is negative 10. So now when you combine your like terms in the middle, we end up with x squared minus 3x minus 10. So notice it's the same as what we got before. So just use whichever method is easiest for you to multiply two binomials together. Okay, in our next example, we want to combine like terms again. So, well, I'm sorry, we're not combining like terms, we're multiplying this one. So x minus 7 quantity squared. When we square something, that means you're multiplying it by itself. So first step I would recommend is to rewrite this as x minus 7 times x minus 7. Because what's tempting to a lot of people to do is to just square the x and then square the negative 7. If you do that, it's going to give you the wrong answer. When you write it this way, you know that you'll have to use distributive property or the FOIL method. And I'm going to talk you through the FOIL method. So we need to do first times first, x times x, which is x squared. Outer times outer, x times negative 7 is negative 7x. Inner times inner, negative 7 times x, again, is negative 7x. Last times last, negative 7 times negative 7 is 49. So now we combine our like terms, and we have x squared minus 14x plus 49. And that would be our answer for part D. Okay, and let's look at our last example for E, where we want to multiply a binomial and a trinomial together. So we cannot use FOIL for this multiplication because FOIL only works if you have two binomials. So this is when we actually do need to apply the distributive property directly. So we can think about what we have in our first set of parentheses as what is being distributed to everything inside of my second set of parentheses. So I'll have x minus 3 times that x squared plus x minus 3 times a negative 2x plus, because again, distributive property is always combined, your terms are combined with addition, and then we'll apply the negative later, plus x minus 3 times that last term, which is 4. So if you want to rewrite this, you can, but you don't need to. I know that I'm going to have to distribute that x squared to everything inside of my parentheses. I'll have to distribute my negative 2x to everything in my parentheses, and I'll also have to distribute that 4 to everything inside my parentheses. X squared times x is x to the third power. Negative 3 times x squared is negative 3x squared. Next, we have negative 2x times x, which will give us a negative 2 x to the second power. So notice I didn't write the plus because we would have had a plus a negative, which we would have to simplify to a subtraction anyway, so we could do that off the bat. We have a negative 3 times negative 2x. Negative times negative gives us a positive 6x. Now we're distributing the 4. 4 times x is 4x. 4 times negative 3 gives us negative 12. So now we combine our like terms. So we have x squared, and then we also have our x's. So we keep our x cubed. Negative 3x squared minus 2x squared. We combine our coefficients to get a negative 5. Variable stays the same since we're just subtracting. 6x plus 4x will give us a 10x. And we have our constant minus 12 on the end. And that would be our simplified answer.